we are bombarded by numbers. Most numbers, like these, have labels that follow them. Now, what is it that these labels mean? I have here a new car sticker, and there are many numbers on this sticker. However, there are some of them that we're going to look at. We're going to look at the ones that seem 18 miles per gallon and 27 miles per gallon. We're going to look at numbers that have labels like these. And Art and I are going to have a discussion about these labels.
Here's a sign that has no label, but we know what the label is. It's 5 miles per hour. So we're talking about miles and time, hours. Over there we're talking about miles and gallons. So they're sort of related, but this is with hours, and that involves gallons.
You know, I have my paycheck here, and I get paid so much money, so many dollars per week. So that's money with respect to time.
Now, these ads in the paper list a lot of jobs that pay just like your paycheck described. Here's a couple of others. This one is $20,000. Doesn't have a label. We know that's per year. A lot of the others, though, list so many dollars per hour. So all of these ads are talking about money and time, but some are per hour, some per month, some per year.
So what we're going to do is we're going to talk about comparing different units of measure, and they're connected in a special way. Miles per gallon, miles per hour, dollars per hour. They're connected mathematically by the operation of division, and that's important to know.
Now here's an ad for a new car that lists miles per gallon. Again, you can see 23 in the city, 31 on the highway. How did they determine how many miles for every 1 gallon this car would get? Well, they took a whole fleet of them, drove them for quite a number of miles, and then divided the total miles by the total number of gallons used. So they divided to get how many miles for every 1 gallon you could expect a car like this to get.
And that's what this label stands for. Miles per gallon means that we're going to divide the miles by the number of gallons that we use. They have another example on this same ad. It says $252 per month. Same kind of label. Per month meaning for each month. And what they've done is taken the total cost of this car and divided it by the number of months it would take to pay that back. And that's how they got that number. You know, we very often do the same thing in calculating our own gas mileage. We do a division problem. I know my car gets about 360 miles for every tank full of gas that I use. And now my gas tank holds about 15 gallons. So if I divide 360 by 15, the answer here tells me that I get about 24 miles to each gallon of gas that I use.
Now that's really an estimate, because you don't always fill up with exactly 15 gallons, but you could estimate about 24 is what you get.
Sure. And this is an example of what these labels mean, that we're actually doing a division. Now, we looked at some very common ones: miles per hour, miles per gallon, dollars per hour. Sometimes other units are combined. Let's look at these examples.
These ads talk about the rates of pay different jobs pay. This one, kind of an interesting one because it lists pay per month. And what the company did is decided how much the job should pay per year and divided by 12. So they get $500 to $600 per month, as the ad says. This one's quite different, though. It's for truckers, and the company has decided that they would pay per mile driven. In this case, it's almost 27 cents per mile. So while all the others were based on pay per time period, this one's based on pay per mile driven.
This one happens to have a real unusual one that we don't see very often. This is an ad for a clerical person, someone who has the ability to type. And as we read through the ad and we get to this fourth line, it said the person must be able to type 45 WPM, which means words per minute. So two different kinds of units, again compared by division. So now what have we seen? We have seen that we're going to take two different kinds of measure and compare them by the operation division. And this is something that we commonly see. We very frequently use dollars per hour or miles per gallon.
I'm going to visit my sister, and it's 400 miles away. So that's 400 divided by 25, because my car gets 25 miles per gallon. Gas costs $1.12 a gallon. So 400 divided by 25 equals 16 times $1.12 equals $17.92. But I have to go up and then I have to come back. So times 2 equals $35.84.
We figured that an acre per head is necessary, but on dairy cattle, I like to have at least 2 acres per head. Although we feed them in the milking parlor in the morning and in the afternoon, still I feel safer if we have more acreage per each cow to be able to support them like they should be supported.
This deal is a once-in-history bargain. The best carpet buys since the dawn of time. Only $6 a square foot.
Hold on. Is that really such a good deal? There are 9 square feet in a square yard, not 3 as you might think. So at $6 a square foot, the carpet would actually cost 6 times 9, or $54 a square yard. That's not such a great bargain.
This little field here is about 1/10 of an acre. And before you can plant your seeds, you've got to fertilize. And most people recommend fertilizer by the acre. For example, I'm planting snow peas here. And the extension agent recommended that I use 150 pounds of ammonium nitrate per acre for the snow peas. Now, since I just had 1/10 of an acre here, what I did was divide 150 pounds per acre by 10 to get the amount of fertilizer that I ought to put on this field right here. And what that worked out to was about 15 pounds of ammonium nitrate for this field.
Have you ever been in this situation? I have to buy some wrapping paper, and either of these rolls will do, but I can't decide which is the better deal. They look like the same amount, but this one cost $1.95 for 15 square yards, and this one cost $3.20 for 20 square yards. I guess it makes sense. It costs more to get more. But is that right? Is the larger roll a better deal? The only way to find out is to find the cost per square yard for each of these rolls. I can divide the cost of this roll, $1.95, by 15 square yards and determine that it cost 13 cents per square yard. The second roll costs $3.20 divided by 20 square yards, or 16 cents per square yard. So the roll with the less paper actually costs less per yard than the larger roll. By reducing the cost to a single unit, we can compare the prices of goods with different quantities. This is called cost per unit. Here's a different type of roll. In this case, the tape is sold by the linear yard instead of the square yard. Both of these rolls are the same width. They can be easily compared using linear instead of square yards. The larger roll costs $3.60 for 60 yards, so its unit price is 6 cents a yard. The smaller roll costs $1.80 for only 10 yards, so it costs 18 cents a yard. The tape on the smaller roll costs 3 times as much per yard, even though the whole roll costs only half as much as the larger roll. I'm buying some candy for a party. I can buy 2 pounds for $3.50, or I can buy 1 pound for only $2. Which is the better deal? This one is simple. We already know that this bag is priced at $2 a pound, and the larger bag is priced at $3.50 divided by 2, or $1.75 a pound. I'm going to buy the larger bag. It works the same with dog food. I can buy a 5-pound bag of dog food for $3.40, or a 25-pound bag of dog food for $8.50. The food in the smaller bag costs 68 cents a pound, while the food in the larger bag costs 34 cents a pound. Here's a bargain. I can buy this 70-ounce bottle of drink for only $1.40. That's only 2 cents an ounce. If I buy it in the 20-ounce, it costs 80 cents a bottle, or 4 cents an ounce. We often see that larger quantities are less expensive than smaller sizes because a certain amount of the cost goes into the packaging. But don't take it for granted. Now this detergent is $8 a gallon, and the smaller size is $3.30 for 2 quarts. In this case, we have to convert the units of one bottle to match the units of the other to allow for comparison. A gallon is 4 quarts, so the larger bottle costs $2 a quart. The small bottle costs $1.65 a quart. In this case, the smaller quantity is the better deal. So far, we've seen unit measures in length, weight, and volume, but sometimes we have to use other convenient units. How do I compare the price of film? That's right, by exposure, or the number of pictures you take per roll. This 12 exposure roll costs 15 cents per exposure. The 24 exposure size costs just over 11 cents, and the 36 exposure size is just under 11 cents per exposure. In this case, the cost is almost the same for the 24 or the 36 exposure size, so I will probably buy the 24 exposure size because it best fits my needs. Many stores list price by their total cost and their unit cost. If you just take a little time, you can read these labels and determine which size offers the best cost per unit. If there are no unit cost labels, you can easily determine the unit cost with a calculator. I have shown you that the prices of goods can be misleading. It pays to take a little time to determine the unit cost in length, weight, volume, or some other measure so that you can compare prices more accurately. Ratios are all around us. We use them when we buy and use chemicals, medicines, concentrated juice, and hundreds of other products. The nice thing about ratios is that they use a single set of numbers to tell us how much we need of one thing when we know how much there is of something else. For example, this weekend I'm going to paint my living room, and I have to buy enough paint to do the job without buying too much. By using the ratio of 1 gallon for every 100 square feet, I can quickly determine how much paint I need. My living room is 480 square feet, which is almost 500 square feet. So I will need 5 gallons of paint. The same ratio, 1 gallon for every 100 square feet, applies to every type and size of room. A bathroom with 200 square feet requires 2 gallons. The ratio 1 gallon to 100 square feet remains the same, regardless of the size of the room. It's easy to be fooled by ratios because they look like fractions, but they're not. If a recipe mixture requires 3 cups for every 2 quarts, it could be written as 3 cups over 2 quarts. But it's not the same as 3 halves. If a person walks for 2 miles in 30 minutes, it might be written as 2 miles over 30 minutes, but it is not the same as 2/30. The difference is that a ratio always compares 2 quantities which have different labels. In this case, cups and quarts, or miles and minutes. Fractions, on the other hand, compares quantities which have the same labels. For example, 2 out of 3 doctors, or 2/3, or 4 games out of 7 games, or 4/7 of the games. Ratios have different labels. Fractions have the same label. The real difference between fractions and ratios is seen when we have to add. When we add 2/5 and 1/4, we first must find a common denominator. 2/5 will become 8/20 because 20 is your common denominator. 1/4 would become 5/20. Once again, 20 is your common denominator. Now your problem is 8/20 plus 5/20. And what would be your answer? 13/20. I certainly enjoy sunny days more than rainy days. Sometimes the weather is expressed as ratios. If the weather was sunny 2 out of the last 5 days, and it will be sunny only 1 out of the next 4 days, the ratios are added together to show an overall weather ratio of sun of 3 out of 9 days. Ratios also look like unit measures, especially when the denominator is 1. However, ratios often have a number larger than 1 in the denominator. In this case, the correct dosage of medicine is 150 milligrams for every 100 pounds the patient weighs. If the patient weighs 200 pounds, the doctor will prescribe 300 milligrams. So it is not a unit measure, but rather a measure for each 100 units. Ratios are also confused with combinational measures such as miles per gallon for the same reason. A ratio is different because combinational units have a 1 in the denominator, while ratios often have denominators greater than 1. Ratios show the relationship between two numbers and labels. That relationship remains the same no matter how big or small the number becomes. This plant fertilizer requires 5 ounces of fertilizer for every quart of water. How much will I need for 10 quarts? It's easy. I will need 10 times 5 ounces, or 50 ounces. The ratio is the same. That is the power of ratios and why they are so helpful. All you have to know is one set of numbers, the relationship, and it never changes no matter what the relationship is applied to.